The magnification of an image can be calculated from the height of the object and the image on a ray diagram. Remember that a ray diagram is a way of determining where and how an image is formed by a lens, which causes light rays from an object to converge or diverge. We'll start with this symbol representing a lens, in this case a converging convex lens. We also draw its principal axis and its focuses, the points that the rays parallel to the axis will converge to. Then we draw an arrow from the principal axis to represent the height and the location of an object. Light rays from the top of the object will refract through the lens and converge at the top of a formed image. We can use the properties of the lens to draw these three key frames, and then deduce that an image forms here. Now remember that the magnification of an image tells us how its size compares to the object. From a ray diagram like this, we can calculate the magnification using the formula magnification equals the image height divided by the object height. But what are the image height and the object height? Well, we can just measure them directly from the diagram. This is the object height, the distance from the principal axis to the top of the object, and then similarly, this is the image height. You might also be given a scale to translate a height on the page to an actual height, such as a 1 meter tall object being 1 centimeter tall in a diagram. Now, what units do we use for our equation? Image height and object height are both distances, so we should use units of distance like centimeters. Technically, you could use any unit of distance, meters, yards, miles, etc. But at GCSE, you'll only be using centimeters and meters. Then the magnification will have no units, since we've divided a distance by a distance. The magnification is just the ratio between these two heights. This looks like quite a simple formula to use, but there can be some tricky questions you have to apply it to. Let's take a look at an example of one now. The ray diagram below shows an object held in front of a concave lens, with its virtual focus marked. The height of the object is 6 centimeters. Calculate the magnification of the image formed by the lens. In this question, we're going to have to construct a ray diagram to find the image height, which is something you could be asked to do in your exam. Other questions might give you an already completed diagram to work from, or directly tell you the image and object heights. In this case, we'll start with step 1. Draw a ray through the center of the lens. Now in this example, we're working with a concave lens. We can tell from this symbol, which represents the lens curving inwards. Like with a convex lens, any ray from the top of the object to the center of the lens will pass straight through it like so. In step 2, draw a ray to the lens and through the virtual focus. Now, unlike a convex lens, rays parallel to the principal axis, like this, will diverge after passing through the lens. To determine where the image forms, we instead draw a line through the focus on the same side of the lens. This represents where the rays appear to come from, based on their divergent paths. In step 3, draw the image where the rays converge. The two rays we've constructed meet at this point here. This is where the top of the image will be, so we draw an arrow up from the principal axis, like so. In step 4, measure the height of the image. We're told in the question that the height of the object is 6 centimeters. Using a ruler, we can determine the scale for this diagram by measuring the actual height of this arrow, though in an exam, the scale might be given to you already. So using an appropriate scale, we can determine that this image has a height of 2 centimeters, and the object is 6 centimeters. Then in step 5, substitute the values into the formula to calculate the magnification. Remember that this is magnification equals image height divided by the object height. So in this case, the image height is 2 centimeters and the object height is 6 centimeters. So the magnification is equal to 2 divided by 6. There's no need to convert the units here as they're both in centimeters. So the magnification is equal to 1/3, or 0.33 as a decimal to 2 decimal places. In an exam though, a question like this would have a range of acceptable answers, since we were measuring from a diagram that we drew. The examiner wouldn't expect this image height to be 100% accurate.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!